some people that are on board, and I'll have that in the slide coming up here in just a moment. But I'm Barbara Miller-Webb with D3 Technologies, and then we also have 3 other 3D systems people on board. We're going to do a quick review of 3D or D3 Technologies. Then we're going to go into the 3D systems capture, scanner review, as well as the Design X and Control for quality control review. One thing I just want to note today is that just by participating today, you'll receive a 10% discount when you purchase a 3D Systems Geomagic Capture Scanner solution.
Your audio is not working. They can see your screen, but
yeah, I'm seeing that you're still on broadcast. Like you have to start the broadcast. Does the attendee still on hold?
Still says it, but it shouldn't. I don't. It's showing my screen.
At the very top of your panel, is there a red bar?
Yeah, and it says attendee still on hold.
Is there a start broadcast next to it?
No. There's not.
Maybe if I do it.
I'm going to try
to change it. I'm going to change. Are you clicking on it?
I'm going to go ahead and click it and see.
Good morning and welcome to the 3D Systems D3 Technologies webinar for Geomagic Capture. And today I am with 3D Systems, and I'll introduce them in just a moment, but I'm Barbara Miller-Webb with D3 Technologies. As far as our agenda, we're going to do a quick overview of D3 Technologies, go into the 3D Systems Capture Scanner review, a little bit about that, and then dive right into the Geomagic Design X for reverse engineering and Geomagic Control for quality control. One thing I wanted to make note here is that by participating today, you'll receive a 10% discount on the purchase of any 3D Systems Geomagic Capture Scanner solution. Keep in mind that the offer does expire 30 days from today. So as a quick review, D3 Technologies actually is a partner with 3D Systems. We provide all of their solutions, including the scanning solutions. D3 was founded in 1988. We're primarily an engineering design firm with offices located all over the central United States, but we really focus on the manufacturing sector, and we help provide solutions for increasing that efficiency, whether it be through technology implementation, data management, automation, or anything else. So that's a little bit about who D3 Technologies is. One thing I would like to just introduce is Michael Dalrymple. He's Solution Sales Manager for 3D Systems Geomagic. Ryan Montgomery, Application Engineer, and Jonathan Pace, who's Inside Sales Manager. And so I appreciate them being on board today and taking us through this process. So right now, I am going to go ahead and turn this over to Michael Dalrymple.
So I just wanted to go ahead and introduce myself. Can you guys see my screen with my mouse moving?
We can.
Okay, excellent. So hi everyone, thank you for joining us today. My name is, again, Michael Dalrymple. I'm a Solution Sales Manager for Geomagic, which is our software business unit of 3D Systems. I have my colleagues Jonathan Pace and Ryan Montgomery along with me who will be helping out with the presentation today. And we'll be talking about our Capture Desktop Scanner and our 2 integrated software solutions, one for scan-based design in Design X, and the other is Control, which is used for inspection. So the scanner software packages are part of an ecosystem of technology that allows users to transition seamlessly from one process to the next. This is what we oftentimes refer to as the digital thread. And this thread ties and integrates systems and software to provide a much better way of designing and manufacturing. Leveraging a variety of 3D Systems product, the user can digitize a physical part, re-engineer a design around it, and optimize it for 3D printing and additive manufacturing. Once manufactured, the user can then inspect the part to verify there are no defects or design errors. If those are identified, the user can make the necessary changes in the manufacturing process or use the parametric tree history workflows in Design X to make efficient design up. All of these solutions in the ecosystems is available through D3 Technologies, who is an authorized reseller of 3D systems. Speaking about today is 3D scanning. So the big question is why do it? What makes it so great? The answer is pretty straightforward. Scanning is simply much faster and more efficient than traditional tools. You can collect millions of points of data within seconds for a better and more accurate representation of the 3D geometry. Not only is it more efficient in collecting data, it makes the next step of converting or analyzing the data that much faster. Now that you have millions of points of information, you can bring that data into Design X or Control and create automated inspection reports or use feature wizards to tackle hard-to-create geometry. Very similar to 3D printing, this technology really shines when dealing with complex design. An organic surface or an intricate detail on a part can easily be captured and recreated with scanner and software, where a set of calipers or CMM would struggle. And there are a lot of applications for improving or remanufacturing of a design that has no CAD files available. This thermostat housing for one of Jay Leno's vintage cars that we did last year is a perfect example. He needed to replace and remanufacture this damaged part, but a 3D model just didn't exist. With 3D scanning, he was able to quickly digitize the part, allowing for quicker CAD recreation. And this is also great for his newer cars as well. He scanned the body panel of his hand-built jet-powered car, the EcoJet, and used our software to design a vent that perfectly fits in the space. We printed out a working prototype. Because of the speed and accuracy of scanning and the strength of SLS 3D printing, he was able to have the parts ready within weeks compared to months. And this is the power of the digital thread. So there are so many useful applications for scanning, whether it's a large-scale project that is too big and time-consuming to gather the data by hand, or an intricate detail or artistic design that is almost impossible to replicate. Imagine trying to measure a plant site or an airplane by hand. Or maybe you want that perfect fit for a phone case, but don't have the dimensions or CAD files from the original manufacturer. You can quickly scan the phone to lock all of its dimensions and build a case that fits perfectly around the body. Scanning makes this all possible and provides the designer a more accurate approach and faster time to market. So the scanners that we manufacture and sell are the Capture and the Capture Mini. There are a ton of different scanner technologies out there to choose from, and what's really great about the Capture is its accuracy and speed. It gathers roughly 1 million points per scan, and those scans are typically gathered in a couple of seconds. It's portable and lightweight, so it makes it easy to carry around or have on your desktop, and it's affordable. It's one of the best scanners you can get out for the market for the money. And it seamlessly integrates with all of our software packages. So that includes Design X, Control, and some of the other products like Freeform and Wrap. So speaking of software, we're talking a lot about the scanning, but what do you do with the data once you capture it? There is a big misconception out there that you can go straight from a scan file to a CAD or CAM software, or that you can immediately print that 3D file, and that's not true. You'll need software to prep that data and interpret it. That is where Geomagic software excels. We're the industry leader when it comes to scan processing. The software leading that charge is Geomagic Design X. This is the ultimate scan-based design solution, and it bridges the gap between scanner technology and CAD/CAM software. What sets Design X apart from any other software solution out on the market, it's the fastest. There's no faster way of creating a CAD file from scan data available. It can create native tree history models using its one-of-a-kind LiveTransfer feature, allowing for design changes much faster and faster time to market. And you can create neutral CAD formats that any CAD system can read. It integrates with our very own Capture, but also has plugins for direct scanning for all the major scanning OEMs, and works with any type of scan part. And that includes long-range scan data and something as small as jewelry design. It also has best-in-class mesh editing tools with parametric CAD built in. So no more using 2 programs to prep the mesh and model. You can model right over the scan data, making the process more accurate and efficient. Automated surfacing tools to create CAD models from organic shapes are included, and easy to use for existing CAD designers because it has CAD built in. So it's a very intuitive workflow. And it works with incomplete or bad scan data. So things that are impossible, you can make possible. So I think that completes the slide. I talked a lot about this technology. So what I'm going to do now is hand it off to Ryan, who will show you what the software can do. If you have any questions during the demonstration, please submit those. We're going to hand this off to my colleague Ryan.
This is Geomagic Design X. This is our reverse engineering solution. It's one of the most powerful reverse engineering tools in the market. And what I'll show you today is the process for taking a scanned model, scanned part, and building a history-based CAD model off of that. So the first thing that I'm going to do when this model comes in is apply what we call region groups. If I build a model in design software from scratch, there's intelligence and perfection built into that design process. Of course, when I bring in scan data directly from the scanner, that information does not have that intelligence built into it. So our region groups analyzes the curvature in the scan data and breaks it apart into segments to add that same type of intelligence to it. And we can use those region groups to help in the data alignment and the reverse engineering process. Design X follows a workflow that's very similar to CAD software, so if you have CAD experience, it's very easy to pick up. We create 2D sketches and we extrude those sketches into 3D geometry. So I'll create my 2D sketch, and I'll take a slice of the model. You can see the solid blue line here is the sectional slice that I'm taking, and that dotted blue line is the projection of that slice onto my sketching plane. And I'll move this slice into a region of the part that best represents the sketch that I'm trying to create. So to start this part, I would draw a rectangle and extrude that into 3D geometry, and then I would add smaller features. So I'll move this sectional slice to a region of the part that gives me that rectangle. Then to create my sketch, I apologize. To create my sketch, I'll use our auto sketching utility. And this is going to find primarily lines and arcs inside of that cross-section that I created and add sketch figures to them. Intelligence is built into that sketch so that you can see that there are horizontal, vertical constraints applied. Tangency is automatically applied. If I have a line approximately tangent to an arc, it will detect that and apply those intelligent constraints automatically. Once my sketch is created, I'll extrude that into 3D geometry, just like I would in CAD. So this creates a solid body. This is the format of a model that I would send out for production. And to continue this process, we'll simply add more features using that scan data. So I'll hide that solid model that I generated. And I'll create a surface to represent this freeform face. If I were going to create a freeform face like this in most design software, the way I would do that is by creating a bunch of sectional slices and then lofting those together. So with this tool, I'm effectively doing the same thing. I'm just going in the opposite direction. The geometry itself is already defined by the scan data, and I just need to recreate those sectional slices. So I can change the number of sections that I'm creating. These pink lines are going to represent the sectional slices. Or I can tell it to use the least number of sections necessary to achieve a certain deviation to the scan data. And when I go to the next step, a preview for that surface is shown, along with the sectional slices that will be used in the loft to generate this surface. Any features that I create in Design X, I can check the deviation for on the fly. So even before I confirm this feature, I can check to see that the feature actually fits the part. And of course, if I want to make any changes, I can add additional sections to areas of high curvature to get closer to the scan data. And then when I say OK, a lofted surface is added to my design tree, along with those sectional slices. So to create something like this from scratch, if I, using any other process outside of 3D scanning, would take a very long time. I'd have to measure quite a few points in able to reconstruct the surface, but using the scanning process, I'm able to do that very quickly and do it in a format that is parametric. So not only do I have a surface that fits the scan data, but it's history-based and tied to these sketches. So if I need to make modifications, I can edit that sketch, adjust these control curves, and that surface will update for me automatically. So now I'll use that surface to cut the solid body that I created earlier. And that gives my solid body that same freeform curvature. I'll hide the solid body again. We'll do one more of those mesh sketches. This time I'll create this large inside cut. So I'll move that sectional slice to an area that gives me a good representation of that wall. Then I'll auto sketch that wall. And since I'm creating this for CAD, if I want solid geometry, I need a closed sketch. So I'll add a few extra figures there. Corner trim. And cut that away from my solid body. So that represents the manual process for creating features in Design X. But we have tools that automate that process even further. We call those our extrusion wizards. And I'll start with some of these revolutions. So to create these revolutions in CAD, I would need to create an axis of revolution. I would create a plane along that axis, and then I would create a sketch on that plane and revolve it around that axis. Using these wizards, I simply select the scan data that represents the feature that I'm trying to create. Of course, scan data is never perfect. Parts are never perfect. And what we're trying to accomplish here is to get back to the original design intent for this part. So I can add user intelligence throughout this process to sort of override the data that's available to me and add intelligent constraints. So in the example here, if I best fit an axis into this, I might find that that axis is slightly off angle. So I can tell it that I know the axis for that revolution is vertical. When I go to the next step, You can see a handful of things just happened there. That axis was fit in, the plane was created, the sketch was generated, and that sketch was revolved around that axis. So even though I was able to create this feature with a couple of clicks, this has the same attributes of a feature that I would generate from scratch in CAD. So if I need to make modifications to that, I can simply edit that sketch. And when I leave the sketch, the model recomputes with those changes. So using that process, I'm able to very quickly generate history-based features and I'll hide that scan data and show the solid body that I've built. We have that same tool for standard extrusions as well. So I select the sides of the extrusion, the bottom of the extrusion, and I tell it that this is going to be a cut. And that feature is generated. So using these wizards, I'm able to create a part that would take 20 to 30 minutes to design from scratch in CAD, and I'm able to build that same part with the same CAD intelligence in a matter of minutes. Once this process is complete, I can transfer this model over to my CAD software using a process that we call LiveTransfer. What the LiveTransfer does is it uses the CAD software's API to rebuild all of the intelligence that we've built around this part directly inside the CAD software. So all of my reference geometry, my planes and axes, all of my sketches, all of my constraints, all of that is going to transfer directly into the CAD software. So to demonstrate that, I'll use SolidWorks. And there's a couple advantages to this process. One, the more obvious advantage is the one that I just mentioned. This entire design history is rebuilt directly inside my CAD software, so if changes need to be made downstream, it's very easy to do so. I can edit those sketches and recompute those features just as if I had created that model from scratch inside my CAD software. The other advantage is that we are circumventing any file translation in this process. So the common CAD formats that you would use to transfer solid models between CAD systems are notorious for having problems. And we're able to get around those CAD formats by rebuilding the model directly inside the CAD software. If I do have problems, it's tied to an individual feature. So we can see here we have an error. And when that occurs, it pauses the LiveTransfer process in Design X, so I can go back and edit these features, and or edit this particular feature, and then resume that LiveTransfer process where I left off. And once I'm done, I simply hit Save in my CAD software, and I can save this file as a native part. So that's Geomagic Design X, our reverse engineering solution. Now I will show Geomagic Control, which is our inspection software. In Geomagic Control, we take scan data and compare it to the original CAD file that goes along with that particular part. So I have the CAD file imported here, I have the scan data imported here, and the first step is to align those together in the same position. We have a number of different ways that we can do that. The easiest is our best fit alignment. That just looks at the geometry between the two components and tries to balance out the deviation across the part. So as soon as this process completes, you'll see the scan data jumps to the same position as the CAD model. Of course, we can also generate features on this model for datum alignment. Once that scan data is in position, typically the first thing we'll do in this process is to do a 3D comparison between the two. So this shows the deviation between the manufactured part and the original design intent. Of course, we can take measurements as well, so I'll create a 2D section here. In my 2D section, you can see that this purple line represents the CAD data. Those black dots represent the scan data. So I can apply dimensions by selecting the type of dimension that I want to create, and then selecting the data that's associated with that dimension. So we'll do a radius dimension, for example. Then I'll lasso select the scan data that I'm measuring. And then I click to place that dimension. We can change how those dimensions are measured. Right now I have it set to best fit primitive figures into the scan data, but we can also tell the software to find the outermost point, as if I'm using calipers, to measure the innermost point, or to measure off the center of an arc. And every dimension that I create here has a tolerance applied to it that I specify, and a pass-fail based off of that tolerance. I'll do one more dimension here. This time I'll do an angle dimension, and I'll select two figures that I want to measure and place that dimension. We can check GD&T by placing that GD&T on the CAD model. So for example, I'll check the flatness of this face. And then we can evaluate that GD&T call out off of the scan. One of the biggest advantages to Geomagic Control over some of its competitors in the market is that it's very much geared towards automation. So if I have multiple copies of this part, I don't have to go through this process every time I scan the part. Geomagic Control just assumes, as I go through and take these measurements, that I intend to do this again on another instance of this part. So an automation module is recorded that stores the entire history of the process that I've used. So you can see we started with the best fit, we created a 3D compare, we took our measurements, did our GD&T, and then we evaluated those results. So if I have multiple instances of this part that I need to check, I can scan each one of those components, put all of those scans into a folder on my computer. Then I can come into this batch processing utility, and I can tell it to rerun this process that I just applied on this particular part on every instance of those scans inside of that folder. Once it's done, I can go into my output directory, and what I'll find is a report for each one of the scans that I had there. By default, the report includes everything that I've checked on the part. So it shows me my alignment statistics, it shows me my 3D comparison, and all the statistics that apply to that comparison. It shows me all the measurements that I've taken and whether those measurements passed or failed within tolerance. Same thing with the GD&T, but of course this can be highly customized, so I can set up this report to exclude any information or include any information, and I can change all the visual elements of the report as well. So if I want to put, company logo on there, I can do that. Geomagic Control also has a really powerful scripting module that's built in directly to the software that allows me to create intelligent processes that expand, much further than our standard automation. So if I find that I'm doing a lot of data processing each time I take a scan, I can record that process in Geomagic Control, and when I do my automation, I can tell it to run any of these scripts in that process. So it makes automating the whole process for inspection very quick and easy. Now I'll pass this over to Danielle to finish the presentation.
Hey, Ryan, pass it over to Barb instead.
To Barb.
And then while he's doing that, it looks like we have a question so far. And the question is, maybe Ryan, you can help us answer this. Have we ever used this for tubes and getting coordinates on them? Which is, I think this was asked during the Design X portion of it.
For getting coordinates, we can extract points in Design X, but Control is really more geared for that. So Design X is when we get into reverse engineering. We want to build a CAD model off of the scan data, and Control is what we use for taking measurements. And there is some degree of overlap between the two softwares. For example, both softwares have a full array of point cloud editing and mesh editing tools built into them. But when we're doing analysis on the scan data, we typically do that in Control because that's what the tool set is geared for. And when we're doing reverse engineering, we do that on the Design X side.
Okay, thanks, Ryan. I got another question that was sent to me. It looks like, what is the pricing for Design X and Control? I'll go ahead and answer that now. The pricing for Design X is $19,950, and that includes the first year of maintenance, which gives you access to technical support and version upgrades. And Control is $15,900, and that also includes the first year of maintenance. And it looks like there's one last question. What are the system requirements? So I'll also answer that one as well. You'll need a CPU with a speed of 2 gigahertz or higher, and then you'll need a minimum of 4 gigabytes of RAM We generally recommend having 8 gigabytes of RAM. The 16 gigabytes and more work best. You also need a dedicated graphics card with at least 512 megabytes of RAM, though we recommend at least 2 gigabytes of RAM on your graphics card for best performance. So it looks like that's all the questions we have. I'm going to hand it over to Barb.
Okay, thanks so much. I appreciate it, Jonathan. And before we end today, I'm just going to start out with a couple of polling questions, if I could. The first one is, I'm hoping that everyone can see it today. Do you presently have a scanner in-house today? And then I have another question, if we could, and that is, would you like to be contacted by D3 Technologies to discuss that scanning options in-house with your company? And I think that that is all that we have today. I want to thank everyone for being on board, and certainly feel free to give us a call if you have any questions or if you want to dive deeper into any of these applications. And certainly look for us on the next webinar. Thanks, and have a great day.